Welcome to this final module where you learn about design patterns that let you build highly autonomous agents, where you don't need to hard code in advance the sequence of steps to take, but it can be more flexible and decide for itself what steps it wants to take to accomplish a task. We'll talk about the planning design pattern and then later in this module, how to build multi-agent systems. Let's dive in. Suppose you run a sunglasses retail store and have information on what sunglasses are in your inventory stored in a database. You might want a customer service agent to be able to answer questions like, do you have any round sunglasses in stock that are under $100? This is a fairly complex query because you have to look through the product descriptions to see what sunglasses are round, then look at what is in stock, and then finally see what's under $100 in order to tell the customer, yes, we have classic sunglasses. So how do you build an agent to answer a broad range of customer queries like this and many others? In order to do so, we're going to give the LLM a set of tools to let it get item descriptions, such as look up if different glasses are round, check inventory, maybe process item returns, which is not needed for this query, but we need it for other queries, get item price, check past transactions, process item sale, and so on. In order to let an LLM figure out what's the right sequence of tools to use to respond to the customer request, you might then write a prompt like this. You have access to the following tools, and you give it a description of each of the, say, 6 tools or even more tools that the LLM has, and to then tell it to return a step-by-step plan to carry out the user's request. In this case, to answer this particular query, a reasonable plan that an LLM might output might be to first use get item descriptions to check the different descriptions to find the round sunglasses, and then use check inventory to see if they're in stock, and use get item price to see if the in-stock results are less than $100. After an LLM outputs this plan with 3 steps, what we can do is then take the step 1 text, that is this text written here in red, and pass that to an LLM, maybe with additional context about what are the tools, with the user query, with additional background context, and toss an LLM to carry out step 1. And in this case, hopefully the LLM will choose to call the get item descriptions to get the appropriate descriptions of items. And the output of that first step can let it select which are the round sunglasses, and that output of step 1 is then passed together with the step 2 instructions, that would be these instructions I have here in blue, to an LLM to then execute the second step of the plan. Hopefully it will then take the 2 pairs of round sunglasses we found on the previous slide and check the inventory, and the output of that second step is then used to another LLM call where you have the output of the second step as well as the instructions of what to do for step 3, pass the LLM to have it get the item price, and finally this output is fed back to the LLM one last time to generate the final answer for the user. In this slide, I've simplified a lot of details a little bit. The actual plan typically written by the LLM is more detailed than these simple one-line instructions, but the basic workflow is to have an LLM write out multiple steps of a plan and then task it to execute each step of the plan in turn with some appropriate surrounding context about what is the task, what are the tools available, and so on. And the exciting thing about using an LLM to plan this way is that we did not have to decide in advance what is the sequence in which to call tools in order to answer a fairly complex customer request. If a customer were to make a different request, such as, I would like to return the gold frame glasses that I had purchased, but not the metal frame ones, then you can imagine an LLM similarly being able to come up with a different plan to figure out, based on what they had purchased previously, which glasses they had bought based on get item descriptions, were the gold frame ones they want to return, and then maybe call process item return. So with an agent that can plan like this, it can carry out a much wider range of tasks that can require calling many different tools in many different orders. One more example of planning, let's take a look at an email assistant. If you want to be able to tell your assistant to please reply to that email invitation from Bob World in New York, tell him to attend and archive his email, then an email assistant may be given tools like this to search email, move an email, delete an email, and send an email. And you might write a system prompt saying you have access to the following tools, and again, please return the step-by-step plan. In this case, maybe the LLM will say the steps for this are to use search search email to find the email from Bob that mentioned dinner and New York, and then generate and send an email to confirm attendance, and then lastly, move that email to the archive folder. Given this plan, which looks like a reasonable one, you would then again task an LLM step by step to carry out this plan. So the text from the first step, shown here in red, will be fed to the LLM with additional background context, and hopefully a trigger search email. Then the output of that can be given to an LLM again with the step 2 instructions to send an appropriate response. And then finally, assuming the email was sent successfully, you can take that output and have the LLM execute the third step of moving the email from Bob into the archive folder. The planning design pattern is already used successfully in many highly agentic coding systems, where if you ask it to write a piece of software to build some fairly complex application, it might actually come up with a plan to build this component, build this component, build this component, to almost form a checklist, and then do those steps one at a time to build decently complex piece of software. For many other applications, the use of planning is still maybe more experimental, is not in very widespread use. And one of the challenges of planning is it makes the system sometimes a little bit harder to control, because you as a developer, you don't really know at runtime what plan it will come up with. And so I think outside highly agentic coding systems, where it actually works really well, adoption of planning is still growing in other sectors. But it's an exciting technology, and I think it will keep getting better, and we'll see it in more and more applications. The cool thing about building agents that can plan for themselves is you don't need to hard code in advance the exact sequence of steps an LLM may take to carry out a complex task. Now, I know that in this video, I've gone over the planning process at a fairly high level, with it outputting a list of steps and then tasking an LLM to carry out the steps of the plan one step at a time. But how does this actually work? In the next video, we'll take a deeper dive to look further into the guts of what these plans actually look like and how to string it together to have an LLM plan and execute a plan for you. Let's take a look at that in the next video.